Numbers shape every moment of our lives, often unnoticed. Your alarm clock, the temperature of your shower, the amount of coffee you brew, each is a number at work. Without numbers, we couldn't build bridges, fly planes, or even bake bread. Numbers aren't just symbols, they're the tools we use to understand reality. This reliance on numbers is ancient, stretching back to our earliest ancestors. Numbers let us quantify, compare, and make sense of our world. How many people in a tribe, how much food for winter? The ability to count and calculate gave early humans a crucial advantage, enabling planning and survival. From counting sheep with pebbles to the algorithms in our smartphones, the evolution of numbers mirrors human progress. Numbers are the language of science, the foundation of logic, and a source of artistic inspiration. The patterns in sunflowers, the rhythm of music, and the equations describing the cosmos all reveal the deep connection between numbers and nature. Every time you check the time or send a message, you're part of a story that began with ancient notches on a bone and continues with today's supercomputers. Long before writing, our ancestors counted to survive, tracking clan members, animals, and seasons. The Ashango bone, with its ancient notches, is evidence of early tally systems. Early counting was physical: a pebble for each sheep, a knot for each day. This one-to-one correspondence was the first step toward mathematics. Cultures worldwide used fingers, toes, and objects to count, leading to number systems based on 10 or 20. These methods enabled basic record-keeping and trade even without written symbols. The leap from physical tallies to abstract symbols was monumental. Realizing that 3 could exist apart from 3 objects was the birth of mathematics. This abstraction allowed us to explore numbers themselves and develop formal systems. The simple act of carving a notch set humanity on a path to understanding the universe. Numbers became ideas, not just objects, a revolution in human thought. As societies grew, so did the need for advanced number systems. The Sumerians created a base 60 system, still seen in our timekeeping and geometry. Their cuneiform script made numbers permanent. Egyptians used a base 10 system with hieroglyphs, essential for building pyramids and managing resources. The Mayans developed a base 20 positional system using dots, bars, and a symbol for zero, a revolutionary concept. Positional notation made calculations easier than older additive systems. These systems enabled trade, law, and astronomy, but each had limitations, like the lack of a true zero. The missing piece was a full understanding of zero, which would transform mathematics. The stage was set for a breakthrough that would change the world. Zero, now fundamental, was once a radical idea. In India, zero became more than a placeholder, it was a number in its own right. In the 7th century, Brahmagupta formalized rules for zero: a minus a equals zero, a plus zero equals a, and any number times zero is zero. These rules gave zero a mathematical identity, integrating it into arithmetic. The symbol, shunya, meaning void, was a simple dot or circle. Brahmagupta's leap moved mathematics into the abstract, beyond counting objects. He struggled with division by zero, but his work laid the foundation for the decimal system. Indian mathematicians created the most efficient system for calculation. Zero was ready to travel the world and revolutionize science and commerce. The Indian decimal system and zero spread west via the Islamic Golden Age. In 9th century Baghdad, scholars like al-Khwarizmi championed these numerals, writing guides that made arithmetic far simpler. The system's 10 symbols, 0 through 9, enabled efficient calculation. Al-Khwarizmi's work gave us the words algorithm and algebra. Europe resisted at first, clinging to Roman numerals and the abacus. But the new system's utility was undeniable, especially as trade and finance grew. Fibonacci's Liber Abaci showed Europeans the power of Hindu-Arabic numerals. As complexity increased, the new numbers conquered Europe, paving the way for the scientific revolution. Zero became the heart of modern mathematics and commerce. The Hindu-Arabic system did more than simplify math, it changed how we see the world. Fibonacci's famous rabbit puzzle introduced the Fibonacci sequence, a pattern found throughout nature. This sequence revealed that nature itself follows mathematical principles. The discovery fueled a shift in scientific thought. The universe is written in the language of mathematics. The new numeral system enabled precise calculations for Newton's laws and planetary motion. Numbers became the bridge between abstract thought and physical reality. Adopting a better way to write numbers unleashed a torrent of scientific discovery. Numbers were no longer just for counting, they became the language of the universe. Even a simple sequence could connect us to the cosmos. For centuries, calculation was manual. Abacuses and mental math ruled. The Hindu-Arabic system enabled pen and paper math, but the dream of automatic calculation persisted. In the 17th century, Pascal and Leibniz built mechanical calculators, automating arithmetic. Charles Babbage envisioned the analytical engine, a programmable computer. Ada Lovelace saw its potential beyond numbers. She wrote the first computer program. Lovelace realized machines could manipulate any symbol, not just numbers. The journey from abacus to algorithm set the stage for the digital age. The idea that logic could be mechanized changed everything. The groundwork for modern computing was laid. The digital revolution made numbers tangible through electronic circuits and binary code. Every digital file, text, image, or sound, is a sequence of zeros and ones. This binary foundation powers science, technology, and daily life. Big data and AI rely on numbers to find patterns and make predictions. Space exploration, from rocket launches to telescope images, is governed by precise calculations. Even the search for alien life looks for non-random numerical patterns. Biology, too, is now a numerical science. Genomes are sequences of billions of coded numbers. Numbers decode the secrets of the universe, from genes to galaxies. Our world is built, understood, and advanced through numbers. The story of numbers is a journey from counting sheep to contemplating infinity. Zero opened the door to negative numbers, fractions, and the infinite. Numbers became a playground for imagination and discovery. Today, fields like cryptography and number theory push the boundaries of mathematics. Numbers are a universal language, enabling global collaboration on science and technology. They connect art, music, physics, and biology, bridging all human endeavor. From tally marks to algorithms mapping the cosmos, numbers are keys to understanding. They build bridges, literal and metaphorical, across knowledge and cultures. The journey from zero to infinity is endless, and numbers will continue to shape our future.